Where do we come from? The Big Bang Theory, simplified. Have you ever stopped to think about where everything around you came from? The starry sky, the sun, the earth, and even yourself. What if I told you that it all began from a single point, smaller than the head of a pin, billions of years ago? Yes, the entire universe, galaxies, planets, and even time was born from something called the Big Bang. But wait, how can we be sure this actually happened? And what existed before it? Was there another universe? Or nothing at all? And what will happen to the universe in the future? Will it keep growing, or could it end in a cosmic finale? In this video, we'll answer all these questions and unveil the most fascinating secrets of the cosmos. You'll discover how the universe took its first steps, how galaxies and stars formed, and even how scientists can still see the echoes of the Big Bang today. Here's a fun fact. Did you know that every atom in your body was once part of a star that exploded billions of years ago? That's right, you are literally made of stardust. If that doesn't make you curious, nothing will. Stick with me until the end, because the universe isn't just a place we live in. It's an epic story full of mysteries, and you're part of it. Ready to uncover this incredible journey? Let's dive in. What is the Big Bang? Imagine the entire universe, every star, planet, galaxy, even the empty space, compressed into a single point. That's the starting point of the Big Bang Theory. It wasn't an explosion in the traditional sense, but an unimaginably rapid expansion of energy and matter. Around 13.8 billion years ago, this extremely hot and dense point began to expand, creating everything we know today. Curious? Here's an intriguing fact. The Big Bang didn't just create matter. It also created space and time itself. Before it, concepts like before and after didn't even exist. It's like trying to imagine a book without pages. And here's what's even more impressive. This expansion is still happening today. Galaxies are moving farther away from each other, and the universe is growing larger every second. So the Big Bang isn't just a theory about the past. It explains why the starry sky we see today is the way it is. Stay tuned, because we'll explore mysteries like what came before the Big Bang. And how do we know it actually happened? I bet you'll be even more fascinated. How do we know the Big Bang happened? Have you ever wondered how scientists can be so sure that the universe began with the Big Bang? The answer lies in the clues the cosmos left us, like a giant puzzle waiting to be solved. One of the main pieces of evidence is the cosmic microwave background radiation, a faint but constant glow that covers the entire universe. Think of it as the echo of an ancient explosion that we can still hear billions of years later. Curious? This radiation was discovered by accident in 1964 when two scientists, Arno Penzias and Robert Wilson, were adjusting an antenna and picked up a strange noise coming from all directions in the sky. That buzz was actually the leftover radiation from the Big Bang, a true scientific treasure. Another fascinating piece of evidence is the redshift of galaxies. When we look at the sky with telescopes, we notice that nearly all galaxies are moving away from us. It's like the sound of a siren that changes as it moves farther away, but on a cosmic scale. This discovery, made by Edwin Hubble, showed that the universe is expanding, just as the Big Bang Theory predicts. And there's more. The amount of light elements like hydrogen and helium in the universe is exactly what we'd expect if everything began with the Big Bang. Want to know what all this means? Keep watching, because the next discoveries will blow your mind. What existed before the Big Bang? Now we come to one of the most intriguing mysteries. What existed before the Big Bang? This is a question that challenges our understanding, because the very concept of before loses meaning when we think about the birth of time and space. It's like trying to imagine what lies beyond the edges of a map, without any edges. Scientists have several theories, each more fascinating than the last. One suggests that the universe could be cyclical, going through phases of expansion and contraction, a big bang followed by a big crunch, repeatedly. Another hypothesis involves the multiverse, where our universe is just one among many, like bubbles in a vast cosmic foam. Could these bubbles collide, and could one such collision have given birth to our universe? Here's a thought-provoking idea. Some theories suggest that what came before the Big Bang might be related to dimensions we can't even imagine. Think about it. We might live in a universe that's just a part of something much bigger, something entirely beyond our current understanding. What about you? Have you ever imagined what might have existed before everything? Stay tuned, because in the next topic we'll explore how the first particles of the universe started to organize themselves. A true cosmic physics show. The formation of the first elements. Now that the universe has started to expand, you might wonder, how did something so chaotic give rise to everything we know? In the first few minutes after the Big Bang, temperatures were so high that atoms, as we know them, couldn't exist. It was like a cosmic soup of fundamental particles, including protons, neutrons, and electrons. But then, something extraordinary happened. As the universe cooled, these particles began to combine, forming the first light elements, hydrogen and helium. This process, called primordial nucleosynthesis, lasted only about 20 minutes, but was crucial in shaping the universe. Here's a fun fact. Even today, approximately 75% of the visible universe is made of hydrogen, the very same hydrogen created back then. And why is this so fascinating? Because without these elements, stars couldn't form, and without stars, there would be no us. Think about it. Every atom in your body is part of this story. You are literally made of stardust, a living testament to the Big Bang. Want to know how these particles evolved to form galaxies and stars? Don't go away, because in the next topic we'll uncover the birth of the largest structures in the cosmos. Get ready to dive even deeper into the universe's spectacle. How did galaxies and stars form? After the first elements formed, the universe was still a dark and formless place. But slowly, gravity began to play its role. Small variations in the density of matter, imagine tiny clumps in the cosmic soup, started to pull more matter toward them. These regions grew denser, and over time the first stars and galaxies were born. Here's something fascinating. The first stars that formed, known as population 3 stars, were gigantic, much larger than most stars we see today. They burned bright and died young, exploding in spectacular supernovas that scattered heavier elements throughout the universe. These elements, like carbon, oxygen, and iron, later became the building blocks of planets, and even us, and galaxies. Think of them as cosmic cities, made up of billions of stars, gas, and dust, all held together by gravity. Some galaxies are so large that it takes light millions of years to travel from one side to the other. The Milky Way, the galaxy we live in, is just one among trillions. Curious to know how we can look so far into the past and see these galaxies? Stay with us, because in the next topic, we'll explore the cosmic microwave background radiation, the universe's baby picture. It's like looking at the dawn of time. The role of cosmic microwave background radiation. Did you know we can hear the echoes of the Big Bang even today? The cosmic microwave background radiation is precisely that, the leftover glow from the initial great expansion. It's as if the universe left a signature of its origin, a visible record of when it all began. Here's an incredible detail. This radiation was emitted about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form. Before that, the universe was so dense and hot that light couldn't travel freely. It was like being in the middle of a thick fog. When atoms started to come together, the universe became transparent, allowing this light to escape and travel for billions of years until it reached us. The most amazing part? We can detect this radiation today with special telescopes, like the Kobe satellite and the Planck telescope. These instruments captured images of the cosmic microwave background, showing the universe in its primordial state, a mix of hot and cold regions that eventually formed galaxies. And here's what's even more surprising. Studying this radiation not only confirms the Big Bang, but also gives us clues about the universe's future. Want to know where it's all headed? In the next topic, we'll explore theories about the cosmos's destiny. Get ready for a journey through time to the end of the universe. The future of the universe. What comes next? Now that we've explored the beginning of everything, it's time to look into the future. Where is the universe heading? Will galaxies keep moving away from each other? And will the cosmos keep expanding forever? Or is there a limit to this expansion? These questions have fascinated scientists for decades. The most accepted theory today is that the universe is expanding at an accelerated pace, driven by a mysterious force called dark energy. Think of it as an invisible motor pushing galaxies further apart. If this expansion continues, the universe might face what's known as the Big Freeze, a time when stars burn out, galaxies disintegrate, and the cosmos becomes dark and cold. But there are other possibilities. One is the Big Crunch, where gravity eventually overcomes dark energy, causing the universe to collapse back into a dense, hot state like the beginning. Another fascinating theory is the Big Rip, where dark energy grows so powerful that it literally tears the universe apart, from galaxies down to subatomic particles. Here's a thought to spark your curiosity. Could our universe be just one cycle in an infinite series of Big Bangs and Big Crunches? Or could it be part of a multiverse with new universes being born right now? While many questions remain unanswered, one thing is certain. The universe is a story in constant evolution, and we're part of it. So, as we gaze at the starry sky, remember, every star, every galaxy, and even you are the result of billions of years of cosmic history. And now, tell me in the comments, which mystery of the universe would you like to explore in the next video? I'd love to hear your thoughts. See you next time, because science never stops surprising us.